Okay, so we're told that Anne and Brenda each have a calculator which can generate a single-digit random number from the set 1, 2, 3, 4, 5, 6, 7, 8. They each generate a random number on the calculator. The first question says, find a probability that the two numbers are equal. Now, temptation on this question is to think about drawing a sample space diagram. So I mean, if we did that, we'd have 8, 7, 6, 5, 4, 3, 2, 1. Along one side, let's call that Anne, and along the other side we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Now that means I'm going to have 8 by 8 rows or 8 columns of 8 answers. There's a total outcomes here of 64, which is an awful lot to actually write out, and a little bit of a waste of time, especially considering the sort of marks we're getting here. So actually, the way I'm going to think about this is, I mean, you could do, we know that its total outcomes is 64. Out of those total outcomes, I can have 1, 1, 2, 2, 3, 3. I can get the 8 different pairs of numbers. So part A, probability the same, will actually be the 8 different pairs of numbers out of a total of 64, which simplifies to give me 1 out of 8. Now there's a slightly simpler way to think about this, and that's that, let's say Anne goes first. It doesn't matter what Anne generates, the chance of Brenda getting the same is 1, because that one number that Anne's generated, out of a total of 8. Okay, but having this sample space diagram can kind of help you visualize what's happening here perhaps. I mean, like I said, you don't necessarily perhaps fill it in other questions you may need to. Part B says find the probability that the sum of the two numbers is 12. So the way I'm going to think about this is, first of all, we could have Anne rolls an 8 and that Brenda rolls a 4. So I'd have this 8, 4. Or that Anne rolls a 7 and Brenda rolls a 5. Or that Anne rolls a 6 and so Brenda would have to roll a 6. Or we could have that Anne rolls a 5 and that Brenda rolls the 7. Or we could have that Anne rolls the 4 and Brenda rolls the 8. The thing what the sample space diagram helps you with here is that you just have to remember we're not looking simply for the pair of numbers 8, 4, 7, 5, 6, 6, because 8, 4 can happen with when Anne picks it and Anne picks 8 and Brenda picks 4, and also when Anne picks 4 and Brenda picks 8. So what we get here is actually there are 5 possible outcomes. So B, probability sum equals 12 is going to be those 5 outcomes that we've just outlined out of a total of 64 different outcomes. Let's have a quick look at the mark scheme for this. Actually, what we're going to get for this, for part A, you get a method mark and an accuracy mark all in one for getting this statement here. And then, so in part B, you are going to get a statement mark for correctly stating all these possible different outcomes, and they have to be those 5 different outcomes. And then you are going to get your method mark and accuracy mark for then correctly getting that the probability is 5 out of 64. Okay, so let's look at part C. It says, given the sum of the two numbers is 12, find the probability that the two numbers are equal. Okay, so part C is actually a fairly straightforward conditional probability question. We're saying probability is equal given we have a sum that is 12. Now, what we know here, this just reduces our problem to this whole set of numbers here. Okay, how many ways can the numbers be equal? Well, there's one way that those numbers can be equal, and that's if I get 6, 6. And how many outcomes is that out of? Well, that is out of a total of 5 outcomes. Okay, So by doing that, what we now have, looking at the marks, we then get, again, our method mark and our accuracy mark. And again, this is all reliant on actually having stated this set here. Okay, hope that made sense, and I hope you understood it.